Hello, everybody. Welcome to Connect University, to our lecture series on digital for sustainability. This is our series of lectures where we explore cutting-edge topics and raise awareness on how digital technologies can be used to tackle some of the great sustainability challenges. This session is being recorded, and the video will be posted online on our external website of the Connect University, where you can also find previous lectures from the series. Our speaker today is Eva Gladek, the founder and CEO of Metabolic, a consulting, research, and venture building firm dedicated to advancing transition to the circular economy. Eva is one of the top influencers in sustainability in the Netherlands, which in itself is a top influencer in circular economy thinking and practice. Eva is an expert in technical environmental management with degrees in biology and industrial environmental management from Amherst and Yale. And she founded Metabolic in 2012 to help organizations not only to develop their sustainability strategies, but also to build solutions for them. And her company has built a large range of solutions, ranging from local, like developing a polluted neighborhood in Amsterdam into a green, circular, smart, hip neighborhood, all the way to a global level where they are building now a data science platform for supporting decision-making in for circular economy projects. And in between, Eva's company, Metabolic, has worked on a variety of projects, building solutions and developing strategies for governments, large companies, NGOs, cities, and they have analyzed food systems, circular buildings. They've built a system for example, for trading renewable energy with blockchain. So there is a great breadth and ambition to their work. They have produced spin-off companies and have recently launched a think tank as well. To wrap up my brief introduction, Metabolic can also be described as a systems consultancy and a technology development firm, because they analyze problems by applying systems thinking and by analyzing data and by building data-based solutions. So this makes it a perfect fit for our lecture series on digital solutions for sustainability. And I am very glad that Eva has accepted our invitation today. So thank you very much, Eva, for coming to speak to us, and the floor is yours.
Thank you very much. It's really great to be here. And this was a really extensive introduction, so I can also gloss over the intro to Metabolic in my own slides. I just had one very practical question. How do I click through the slides? Is there any, can I actually do that here or no? Sorry. Well, while I'm waiting for the clicker, I wanted to say the core thesis of my talk today is that digital transformation is absolutely critical to achieving the sustainability transitions that we need to achieve. So that's the main argument. And I want to show some of the work that we've been doing, but also that others are doing, to use digital technologies of different types in tackling these issues. And also, I want to start out by explaining why the issues are so complex that they require this digital transformation and these digital solutions. Maybe relevant to mention that we are currently also doing a couple of interesting projects with DG Connect. So one of them is actually exploring digital ledger technologies for social and environmental benefit. And that's actually being led by my colleague, Elizabeth Corbin, who's sitting in the front row. So there are also people who have come with me who can also answer more questions in detail on those topics. Okay. Well, in that case, I'll start by explaining this introductory slide that's up here. So I just want to frame the setting first to, well, very briefly explain what metabolic is, but I'll gloss over that. Then I want to talk about my personal motivation for getting into this field, because I was not always going to be involved in the environmental sector. And I had a few personal realizations that I want to share with you for why I got involved, and also the discovery of why we're currently failing at tackling many of these different environmental challenges, and the conclusion that we actually really need a systems approach. And that is fundamentally driven by a deep sort of understanding of the data behind all these different systems that we're trying to transform. And then explaining why we need new tools. And I want to take you through 4 different types of cases for which we've been using digital technologies and different types of tools, and how we actually have to evolve the current toolkit. And finally, some conclusions. And I'm going to talk about that in just a moment. There's no way to do it? Okay, so next slide, please. That's okay. All right, so very briefly, this has already been explained, but metabolic is rather than an organization, it's an ecosystem. So we have 3 different entities that are operating toward the same mission. We have a consultancy, a think tank, Metabolic Institute, and our venture building arm. And this acts as a kind of pipeline. In the consultancy, we are scanning the market and collecting a lot of data and understanding how different sectors are working, and identifying leverage points for transition, which we then feed into the Institute, the think tank, for further research and the development of open source tooling. And if we identify places where we can intervene ourselves, we actually do our own R&D and tech development and build ventures around the solutions that we find suitable. And all of this is actually being funneled towards one mission, which is to transition the global economy to a fundamentally sustainable state, which for us also includes circular to a large extent. Next slide, please. So as I mentioned, I wasn't always going to be involved in sustainability. When I was growing up, my parents were both immigrants from Poland to the United States. They were very keen on the American dream and the capitalist economy in the US, and really focused on me and my brother getting an excellent education. And I was going to be a molecular geneticist. And so I started working in laboratories very early. Next slide, please. Where I grew a lot of bacteria. And this is what you commonly do in laboratories. So here you see 2 flasks. One of them on the left side is cloudy, and the one on the right is transparent. And these contain E. coli, so common cells that you grow in laboratory contexts. And I had this visceral realization during the process of growing these bacteria at one point about exponential growth and its nature. So what I would do is I would take a few cells from this full flask and put them into a new one, and then I would wait for 24 hours while this flask would sit on a hot plate and the bacteria would grow. And for the first 23.5 hours, it would look like there was nothing happening in this flask. It was just transparent. And then in the last half hour, you had to be very vigilant and really carefully watch it, because suddenly the flask would be entirely full and the cells would start dying. And that's because of exponential growth. So the cells are growing at the same rate the entire time. They're going from 1 to 2 to 4 cells. But toward the end of the growth cycle, of course, the flask is going from being half full to all the cells dying in that very rapid time increment at the end. So I really had this realization of, wow, exponential growth actually can change an entire system from being totally hospitable to totally inhospitable in just a blink of an eye. Next slide, please. And I didn't really think about that so much until I went to university to study genetics. And I had to take a course in environmental science, a course called Extinction, where I ran into these graphs. So these are all the same kind of exponential growth curves, these hockey stick growth curves that I saw in the E. coli flask, but except now they're describing what's going on in our own habitat. These are all different parameters that are essential in one way or another for life on Earth. And of course, we have population growth on the one hand, but we also have resource consumption, loss of ecosystems, changes in different atmospheric conditions, and they're all changing on this exponential level. Now, I have to say, when I saw this, I was very alarmed. I thought, well, I know how this goes in the lab. Is anyone actually paying attention to, is there an Earth management dashboard? Is someone steering this to make sure that we're not going off the rails? And so I started to investigate that further. Next slide, please. And I discovered all of the different sustainability challenges that are both behind these curves and also resulting from them. So everything from drought and famine and all sorts of other environmental issues. And of course, you're all very familiar with them. Next slide. But as a scientist and a biologist, one of my main questions was, how far do we have before we hit these tipping points? If we're on these exponential growth curves, when will the system flip from a habitable and hospitable state to a non-hospitable state? So fortunately, I'm obviously not the only one thinking about this in this way. The Stockholm Environment Center produced this framework, the Planetary Boundaries Framework, in around 2011, which aims to answer exactly that question. Could I just see by a show of hands how many of you have seen this framework before? All right, so I would say around half. That's great. And so, of course, here we're looking at 9 key Earth systems that have to be kept in a safe range of operation for Earth to be habitable. Not even for biodiversity to be flourishing, but just for us to be able to live here. And these have been quantified to the greatest extent possible. And as you can see, biodiversity loss is extremely transgressed. The WWF estimates that in the last 40 years, we have lost around 60% of the populations of key species that they're monitoring. And so by exponential doubling, that would mean that we have another 20 years to figure this out if we don't want to lose the remainder. So these are really grave figures. And then also at the bottom, we have biogeochemical flows like nitrogen and phosphorus, which are things that are not as sexy, that are not just talked about in the media as much, but they're extremely critical for maintaining the habitability of the planet. Next slide, please. So, of course, this is not news. Many of us have been aware of these different environmental issues for decades, and we're obviously taking action. Next slide. There have been hundreds, if not thousands. Oh, did you find a clicker? Amazing. Thank you. There have been hundreds, if not thousands, of different eco-labels. At this point, it is pretty standard to report on environmental, social, and governance metrics, and there's been a lot of investment in different environmental measures. The theory that drives a lot of policy and a lot of decision-making around sustainability, also in corporate environments, is something called eco-economic decoupling. And this is, of course, very centrally referenced in many of the documents that the Commission produces. So the idea is that we are going to be able to continue growing our economy, which is believed to be the primary driver of human well-being, though there are many disputes about that in the literature. And that while we grow the economy, our efficiency of resource use will decrease. So per euro generated, we use fewer and fewer resources until we reach some kind of nullification point. Now, this is a great theory, except the problem is that in many types of impact, in most types of impact, we have found that we're not actually able to achieve the necessary level of eco-economic decoupling, especially not quickly enough. And so what we're seeing is that we are getting relative decoupling, that per unit of economic throughput, our resource inputs are going down indeed, but not as fast as the economy is growing overall. And so we're still on an absolute level increasing in our impact, even though we're beyond some of these thresholds. So the question that I had was, why is this happening? Despite this investment, despite a lot of good thinking and a lot of effort, and one of the answers that we believe in that strongly explains this is that we're not looking at the system level correctly. We are looking at little pieces of the system and optimizing them, but this is creating new problems at times, and this is also not dealing with the biggest scale that we need to be dealing with. So I'm going to go through 3 pitfalls of not using systems thinking for why these results are occurring. The first one is something we call efficiency rather than effectiveness. Does anyone know what this device is on the screen? Anyone have an idea? Yes, it's an electric pepper grinder. Now, you can of course say, like, there are companies out there that are aware of this eco-economic decoupling imperative and have said, okay, well, we need to decouple. Therefore, for each product that we have, we want to decouple the impact of that product by 4 to 10-fold, which is what has been kind of assessed as the amount that we need to absolutely decouple. But then you might ask, well, do you really want to spend a lot of resources and energy optimizing this device rather than asking, does this device need to exist? Do we need electric pepper grinders? And of course, you can say, sure, for certain applications, if you have arthritis, et cetera, but this is just a point to illustrate that many things in the system, we are taking little pieces and optimizing them rather than looking at the big picture and saying, does this actually need to exist? Is this structured properly? So just like with vehicles, for example, you can optimize the efficiency of cars, or you can look at road structures and decide how do you structurally reduce the demand for vehicle transport. Another issue is something we call burden shifting, and this is something that we mention almost every day at Metabolic. So here you see 3 different lighting technologies: the incandescent bulb, which is no longer very visible in the economy at large, then the CFL, or the in Dutch it's called it's also known as a mercury lamp, and then we have the LED. Now, of course, the incandescent bulb produces this lovely light spectrum, very similar to sunlight, and uses a lot of energy. So, of course, there was a desire to move away from this lighting technology to something more efficient. If you were a designer, then that was given just that objective, make this lighting technology more efficient, you might produce something like this middle lamp, also known as a mercury lamp. Now, mercury is a compound that we're trying to get out of our environment. It is bioaccumulative, it is a neurotoxin, it is ending up in our food system. And so if you're just optimizing for one parameter, for energy, you may actually burden shift, so solve an energy problem while creating a health problem on the other hand. So this points to the importance of looking at integral solutions, where we're constantly, even though we're focusing on CO2 emissions reductions or energy reductions, we also look at how those are going to affect the different parameters that we also care about. And this is exactly the problem that emerges when we work in silos and don't interconnect on different types of solutions that we need to find. And the last one of the systems pitfalls that I want to introduce, there are more, but this is the last one I'm going to talk about today, is something called the rebound effect, or Jevons paradox. So what has been found is that this is the statement that summarizes it: technological progress that increases the efficiency with which a resource is used tends to increase rather than decrease the rate of consumption of that resource. In simple terms, this means if you make cars more efficient, people will just drive more cars and drive them more often because they've become fundamentally cheaper and more accessible. And so instead of actually solving the problem that you set out to solve, reducing the energy consumption and the CO2 emissions, you'll actually increase the effect as a whole. And so there are many other types of rebound effects that continuously appear in the system, where we take an action, and sometimes because we don't understand the dynamics of that system, it results in unexpected or unexplained events. So what do we do? It is not dire. There are many ways to solve these problems. What we see is that if we take a systems approach, if we really understand that what we're trying to do is solve this Rubik's Cube puzzle of issues, and that we need to find the algorithm for solving that, rather than focusing on moving one little square to a different location and then messing up the entire puzzle, then we can actually identify genuine solutions and genuine pathways to potential decoupling. Of course, there's a bigger question around decoupling as a whole, as a theory, whether the kind of economic growth on a finite planet can be sustained at all. But if we have any shot of achieving decoupling within the current framework that we have, then we need to take the systemic approach. So fortunately, we found that all problems stem from a smaller number of root causes, and we need to identify those root causes and continuously be looking for them. Exponential challenges like the ones we've created with these different exponential growth curves can be addressed by exponential solutions. Just think of how quickly CDs and VHS tapes disappeared when we had a solution that provided actually a digital option and dematerialized that entire sector. It was almost overnight that these things transformed. So we are capable of identifying exponential solutions. And using systems theory, we can actually identify lasting points, leverage points for change. For us, the circular economy, the way that we've defined it, is actually a framework that will allow us to find pathways to true eco-economic decoupling and to bend these exponential curves. And this is what we all must be focusing on. So I'm not going to talk about the circular economy too much, but we have defined 7 pillars of the circular economy. So these are the characteristics that a circular economy should exhibit when it's been implemented. And you start with, of course, the prerogative that, or the requirement that all materials are cycled at high value indefinitely within this economy, but you have to do that without burden shifting. So we have 6 other parameters that have to be adhered to while you're moving toward that closed cycle system. And we incorporate this and use this as a set of metrics to understand how we can move towards these types of exponential solutions. So we need to transform the economy in a pretty fundamental way. How do we do that? We have a systems transformation method that we use for every system. It's very much aligned with our own theory of change. First, understanding the current state of the system and really mapping out those dynamics and those relationships, identifying the root causes for why it's functioning the way it is, and then setting a goal and a vision of where we need to go. It's kind of like plotting a route on Google Maps. You first need to know where you are, and then where you want to go, and then you can find various pathways to it. So it's quite straightforward. And then finally, using a very data-driven approach to identify those pathways and weigh the different types of interventions that can be applied and how the relative impact, relative cost of those stacks up against different things and what capacity is needed to be built to actually follow through that transition pathway. I'm actually going to skip this graphic. Well, maybe not. So in order to identify where to focus as an organization, we several years ago did this analysis of the entire global economy in terms of its material flows. So this is a Sankey diagram. Each line in the diagram represents the amount of material going through the economy. And here you can see at the very end, this is what is recycled per year. So it's actually a very tiny amount compared to the massive quantity that we're extracting. And we did this analysis to understand in our own sort of systems way where we should be focusing. And we actually developed these 6 major transitions that we believe need to take place very rapidly in order for us to achieve the results that we're trying to achieve. So these are our focal areas. We're focusing on the food system, on habitat, so cities and the built environment, also in rural areas, on industry, so this is kind of where the materials and resource management transition comes in, on human mindset, which is actually the fundamental paradigm shift that has to take place for these transitions to work, finance, and on governance. So in order to do this, it's clear that the tools that we have right now are actually not adequate, that we need huge amounts of data to really understand these systems and the dynamics behind them. And so now I'm going to explain the different case studies that I want to show you on how we've actually been trying to incorporate this new way of systems thinking into the standard ways of doing environmental management. So the first one is on science-based targets. Now, how many of you have heard of science-based targets? Please raise your hand. A few people. And how many of you have heard of life cycle assessment? More people. That's great, but I'll still explain it. So life cycle assessment is the state of the art when it comes to assessing the impact of a product or a service. So for example, this clicker, if I wanted to know, okay, what has the effect of this been on the environment? How has this negatively affected the world or positively? I would generally say, okay, well, let's do a life cycle assessment. So you take apart all the different components, and then you actually sketch out how the entire thing came to be. So where were the raw materials extracted? How were those processed? How were those then put together and assembled? And what's going to happen to this after it gets thrown away? And so you assemble this life cycle chain, and then you quantify at each stage what is going in and what is coming out of that chain. So you're basically trying to understand the inputs and outputs. And then you sum all of that into a kind of aggregated number. And you can then say, okay, well, this thing has had a footprint of, I don't know, 2 tons of carbon and 500 cubic meters of water in its entire production. And then you have a sense of comparing this against maybe this plastic cup. So it starts to give a kind of basis for comparison. Now, unfortunately, there are lots of challenges with life cycle assessment, even though it is a state-of-the-art, well, first of all, it's actually very expensive. So you can imagine that if you want to take apart this product and really see all the different pieces and trace them back to where they are, in an estimated way, it costs 30 to 60,000 euros per product to do such an assessment. Supply chains are also notoriously complicated, and companies don't often have that data. So this is actually a graphic of part of a life cycle breakdown that we did for a smart meter, so a standard piece of electronics. We actually took the product and took out all the different components and had to trace back the likely pathway from where they originated based on their names and codes. And this shows you that it's thousands of different pieces along that pathway. And this is even an abbreviated version of that life cycle. And so even if companies have access to their own impact data, they often don't even wish to share it, which is a big problem. We have to get through this kind of wall of lack of sharing and lack of transparency if we're going to start making the right choices about how to optimize products. But even beyond that, even if you manage to do the perfect life cycle assessment, it's still insufficient in certain ways. So first of all, it does not relate the impact of this product to absolute system boundaries. So we have these planetary budgets that have been defined by the planetary boundaries. We know how much carbon we can emit in total over the next 20, 30 years if we want to stay at 1.5 degrees C. And life cycle assessments do not relate the, if you get a number like 2 tons of carbon for this device, do you know if that's a lot or a little, or does it matter? Is it enough? The other thing that is missing is that impacts are not, they don't include space, time, or context. So for example, here, this is a map that shows water scarcity. Now, in a life cycle assessment, you add together all the water that's been consumed in the production of this product, but it's just one number at the end. It just says this many cubic meters of water. And it actually makes a really big difference to the impact, whether that water was withdrawn in a red area, which has high water scarcity, or in a yellow area, which is completely fine. And so that actually completely changes, or should change, your interpretation of that. But that requires even more data, because you then need to actually have data per supply chain point, and have the actual temporal data. Did it rain in the last year, or is there a drought condition, et cetera? So even standard data sets are not enough there. Of course, life cycle assessment also doesn't take into account product or system design. So these bigger questions of, should this thing exist? Is it at the right level of the system that we're impacting the issue? And it also is based on average product lifespans and usage rather than product specific. So the actual impact of a product can be very different depending on how it's actually used and deployed. So one of the pathways forward that we've been exploring is contextual science-based targets. So really trying to bring in a lot of these things that I've mentioned, so really understanding context, space, and time in terms of where the data is collected, and also linking that to absolute planetary or regional boundaries. A lot of these global boundaries have to be actually downscaled to a watershed or to a really relevant impact shed that we're looking at. We recently did a project with WWF and Alpro. Alpro is it's actually a Belgian company. I don't know if you're all familiar with it, but they produce dairy alternatives, so milk and yogurt that are made out of plant-based goods. And they really are very committed to being a company that fits within planetary boundaries. So they asked us to try to pilot a methodology around this. We looked at their almond supply chain, and we looked at actually specific almond farmers in their supply chain to see whether they were crossing planetary boundaries on water, nutrients, biodiversity, and land use. And so here are 3 of the farms that we considered, and we actually developed and piloted these methodologies. And so we actually developed a whole kind of boundary setting technique for land use to really understand, okay, so is the land being used appropriately in this biome, in this region, and then translating that from the landscape scale to the farm. Now, this was a really great exercise to start to understand, is it possible to develop methods that can allow us to assess on a farm level or company level across the supply chain whether planetary boundaries are being crossed. But we ultimately also know that this is not going to be possible without large-scale data sets and automation. We have to actually have large GIS data sets that allow us to plot where different activities are taking place, and those need to be linked to weather data, and they need to be linked to updated soil data, and this should be ideally a kind of uniform data set that then allows us to do these types of assessments really quickly, because otherwise this is not accessible to actually decision making, and the best thing that we have is these really coarse life cycle assessments, which is actually the way that most decisions are currently being made. In the future, we hope that there's going to be a lot more opportunity for real-time data collection across supply chains as well to get even much more accuracy. So this is a company out of the UK called Provenance, and they're using blockchain technology to track and trace the exact provenance of different products and their components. And so they're doing this now with a couple of dozen companies. And of course, there's still a lot of technical issues that need to be worked out, especially around tagging materials and making sure that you have like a digital or molecular ID so that you can't corrupt the information about the origin of that product or good. So the next case study is around financial risk assessment. So one of the things that we've been doing a lot of work on is trying to get the financial sector to recognize the different types of environmental risks that it's facing, and that the tools that they're now using to assess those are inadequate. And one of the reasons that they're inadequate is because they don't take into account systems dynamics. So a lot of the tools that are used for financial risk assessment are fairly simple, actually, and there's a lot of linear models that are produced. So for example, normally a financial risk assessment might say, okay, well, the risk is going to increase along this line based on our algorithm or our model. But the environmental system is complex, and there are many different interlocking feedback loops and tipping points. And so actually risks in the environment resulting from environmental impact can actually be slow building and then suddenly spike, or be de-anchoring like this one, where it progresses along a line and it looks like this might continue, but suddenly it tips to another state of equilibrium and then goes along a different line, or actually be a kind of drastic point in time acceleration. These are all real risks or patterns that we see in environmental systems. So what we actually have been trying out with different organizations is to use dynamic systems modeling to understand how different environmental systems can then impact financial risks. So this is actually a very simple model that we made of feedback loops in the Amazon forest affected by different things like climate change and forest fires, et cetera, also done for WWF. And then WWF asked us to extend that type of work to develop a model to estimate the financial risk to assets in particular in the blue economy. So all the economic activities related to oceans and basically water-based systems. So that could be like tourism or coastal infrastructure or shipping or fisheries, et cetera. So we actually chose the Baltic as a focal area. And we looked at two different types of asset classes, ports and fisheries. And we developed a really complex dynamic model using Stella, this systems modeling software, to then look at how these risks would change over time and what would that actually mean. Oops, I don't know if somehow I clicked through very rapidly. And what that would mean to these different asset classes. So here we looked at the total port asset value loss, also resulting from storms becoming more frequent, and also the recovery time between the storms decreasing to the point where you actually can't recover the assets in between. And then also looking at the fisheries losses and the kind of cumulative losses in fisheries over a certain period, resulting also from the water being too warm for the fish to hatch, and all sorts of different cycles occurring in that way. So we think that that's actually a very promising direction for financial risk assessment to also better connect the world of environmental analytics and finance to actually better align decision-making in that space. But of course, it requires a huge amount of effort and data and a new mindset for these managers. Next is geospatial analysis. So a lot of these things that we're looking at require geospatial analysis. And so some of these cases overlap a bit. But I wanted to call this one out separately because it's so critical. A lot of the work that we do involves making these Sankey diagrams of material flows. So how much material is coming into a system, how much is coming out, how is it being transformed or used. And this is a flat material flow diagram that just shows inputs and outputs in, let's say, a particular industry or context. But what we've been trying out now for various reasons is geospatial material flow analysis. So we know that impacts vary tremendously by spatial context. In a city, one neighborhood may be completely different from another. And that means that policy recommendations should ideally be tailored differently to those neighborhoods. If you imagine, for example, that you have a target for climate change impact reduction in a city, and you have an old city center where the buildings are really dense and really old and they're mostly monuments, it's going to be very difficult for that part of the city to supply that renewable energy or to even modify those buildings at a reasonable cost for them to be energy neutral. But there are other neighborhoods that can compensate, that have different types of characters. So we've been trying to also characterize neighborhoods based on their stock and material flow by doing this kind of spatial material flow analysis. Repair is also a European project that we participated in to do this. And these are some of the results of showing real-time, for example, food waste flows, which can then tell you where you should put a waste processing facility in a much more accurate way. Another thing that we've been doing, and we've been developing tools around this, is also to understand the current stock. So developing models to say, okay, how much metal is in different buildings or in vehicles, and how can that potentially be harvested in the future? How can you do economic planning around that? And lastly, this is a broader sort of category, which also connects to the other things that I've shown, automated impact assessment. So it's critical that once we get these impact assessments to this level of complexity, that they are automatable. We have to be able to actually automate finding the results, otherwise it remains too expensive and inaccessible to most people. In line with that, we developed for a bank in the Netherlands, ABN AMRO, a kind of initial study or to look at how we could automate scope 3 carbon impact emissions from their investments to actually use different kinds of data that was readily available and make that assessment. Likewise, for ABN AMRO, we developed an automated real estate assessment tool that combines these different geospatial factors and actually looks at their entire portfolio across performance on climate change transition, circular economy transition, and the societal transition, which are their 3 focal areas. And actually, the vast majority of these metrics, we found that we could calculate automatically using existing data. There are some gaps in the circular economy metrics, but we also realized that now that certain new regulations are coming online, more of this data will be available. And lastly, I wanted to show, this is the last example I have of a tool that we've developed for design, for changing the way that designers are approaching products. Because ultimately, when transitioning to a circular economy, we know that we can't continue dealing with the legacy materials of the past that are coming down the pipeline, which are not actually well suited to being recovered for high value use. We actually have to change the way that products are being designed. And for that, we need to give a lot of complex information and complex inputs, all these insights on systems thinking, et cetera, but boiled down for a designer. And so ChemDSS is a tool for formulated chemical product design. So like shampoos or paints or glues. People are able to actually input the different chemicals that they have. It identifies immediately whether there are any regulatory restrictions. It also immediately reads out the toxicity for humans, the environment, as well as the environmental footprint. So then you can immediately start to compare the footprint of the potential product that you want to make before you've even committed to making it. Because lots of products now, they make them first, then they do an LCA, and if it's good enough, they give it a green stamp. And that's not the order in which we should be making these types of decisions. So there's a huge amount of potential in all of these spaces. So to conclude, I hope that this convinces you that without digital solutions of different types, we are not actually going to be able to succeed at these transitions. We need robust insights quickly, inexpensively, and in as close to real time as possible. And there's a host of different solutions, from DLTs to artificial intelligence, that have to be brought together to actually make this possible, and especially also data management and large-scale data availability. And so we also need sustained investment in this space and innovation. We actually need to move in this direction collectively and recognize that this is actually a core part of the Green Deal, for example, and not just a peripheral thing. And this image is actually a kind of moonshot for us. Ultimately, I would love to see a kind of digital Earth platform where all of these different data sets are integrated, where you can plot supply chains, where it's open access, and you can actually very readily and quickly identify these issues. And so this is the kind of thing that we would love to further discuss with you all. Thank you very much. That is the end of my monologue, and I would love to hear some questions.
Great, thank you, Eva. Questions? Manuel?
Thank you very much, Eva, for this very good presentation. We are currently working together with the different DGs of the European Commission towards a new circular economy action plan for the 5 years to come, with a very big focus on products policy, and obviously this link that you very well mentioned to planetary boundaries. And in that context, the importance of the design of products is paramount. The importance of looking at the environmental footprint methods is essential. But indeed, we need the data, and we need to make sure that we have common data space for our purpose. So a question to you would be, if the European Union was to set a digital data space to achieve that, what would it look like, on the basis also of your practical experience with companies?
Yeah, thank you. That's a very good question. So I think there's a lot of open data already available. but a lot of it is scattered and also not in the correct format. I think there should be, so first of all, there should be an exercise to bring all of that data together, to pool it and also to make it into a kind of similar interoperable format. And secondly, to set standards for data reporting from companies and to start putting pressure on organizations to report certain types of data. It should no longer be all right to actually hide some of this data. And that can also happen through regulatory means. It can also be voluntary initially. So for example, I don't know if anyone knows of the company Oatly. They make oat milk, and it's a company out of Sweden, I think. And they've been putting pressure on, they've been reporting their carbon footprint, and they've been saying, show us your carbon or show us your numbers to everyone else in the industry. And I think there are voluntary movements that can happen in this way. Also, consumers can demand more of it. But I think the first step would be pooling that data and also figuring out a great coherent way to display it. So using geographic interfaces in one case, and in other cases like various standard databases. I don't know if that answers your question sufficiently. But.
Okay, next question. Yeah, you.
Yes, hello. Andreas Röfer. You showed us this example of the electric pepper grinder.
Yeah.
And this, of course, raises some questions. First, this is a product which is available in the market, so I would conclude that there is demand for it, that there are people ready to produce it at a price which is profitable. And then there is somebody showing us this slide and says this is not necessary. So my question would be, on which basis would you make such judgments, and who would you think would have to do such judgments? And why are such judgments necessary? Would it not be possible to have the system redesigned in a way that something like this, if you say this is not necessary, would not appear in the market?
Can you all hear me? Okay, that is a really good question. Of course, that does raise a lot of issues. The electric pepper grinder example is mainly to illustrate this very simple kind of point of looking at something too small in the system and optimizing for that rather than looking at the system at large. And it's not to say that we would immediately go out there and say, well, ban all electric pepper grinders or all products that we decide are stupid. But I think what I would really like to see, and I think what's necessary, is a broader common understanding of circular design principles, which also should include why products exist, and encourage reflection from designers and from different people who are creating the products that are going out into the market for whether these are things that are fundamentally good, whether they're advancing the objectives of the entire of society at large. And I think that is a kind of bottom-up way that these changes should ultimately progress. Now, in terms of whether you can design a system to absorb any kind of level of stupid products, I don't think that that's necessarily the case. We've done a lot of research on material scarcity and availability. And for example, we recently published 2 studies on critical metals needed for the energy transition. And we found that for certain materials, we need 14-fold more than we have projected to be produced. It's not that they don't exist in the ground, but that ramping them up in time and actually creating new mines, which take long permitting processes, is going to result in a shortfall. And so we are actually going to have certain shortages of types of materials to even achieve the IPCC guidelines. And so we actually have to start getting good feedback to designers, to people who are using materials, to make sure that these things are being used appropriately. And for example, if you're going to use a critical material, there should be a guideline that says it has to be removable at high quality in the way that you've designed it and put it into a product. It has to be able to be recovered for other uses, and potentially even a timeline to say, okay, well, we need this out of stock and back into the economic stock in 10 years. So there are some kind of steering mechanisms that we need and should have to make sure that we're actually making the right decisions around material management.
Hold your questions. I'm just looking at, we also have a web link to Luxembourg. Any questions from Luxembourg? Not at the moment. Okay, I can't see any hands raised. We are also being web streamed, so Andrea is maybe monitoring. Let me know if there are any questions from the outside. Okay, so over to this room, Christina, and Well, a question here and then a question there. So let's take three maybe.
Yes, hi. Perhaps a remark based on the previous question, which is an interesting one. If we think that we want to let the market decide whether a product is desirable or not, well, then in this case, the price should reflect the cost and the real value of the product, which is not the case at the moment. We're not factoring in, for instance, the impact on the environment or the social impact of the products that we're selling on the market. So if you are of that perspective, then I think we need to revise also the way we put value, and the indicators that define that value are still to be defined, I believe. And then there comes a question. We are working in my unit on the topic of green data spaces, and one of the topics that we're exploring is how can we build a data space that would support the type of solutions that you're proposing. But it seems to me that it's very difficult to build a data space that would, collect any sort of data, be it public or private, without having a use case behind, because it's very complex. As you said, there is a large number of data sets that could be useful. You could have a very sophisticated analysis, but you should probably start with a more simple way of, defining the product elements and the data behind those elements. So would you have some advice based on your experience on where to start? And the governance issue of the data is probably also one of the key issues, right? Thank you.
Yeah, okay. It was on and off. So definitely, we can't start from the whole big picture. We have to build things up in layers. That's definitely critical through use cases. And there are different use cases that you can indeed start with. So for example, looking at just optimizing for carbon impacts within supply chains and then seeing what type of data is needed to do that appropriately, or land use impacts or these kinds of things. But this is something that I'd be happy to discuss maybe after or in more detail later. And in terms of data management, there are many ways that I've seen applied in the market where companies actually submit their private data, and that data is used to do a kind of impact assessment, which then results in a score. And that score is then provided publicly, but not the underlying data. And that can sometimes be enough. So there are different ways to create shields of certain types of information. And of course, aggregation of data is another way that we can solve this, as long as companies are participating on some level and trust at least the government or some entity to collect that data and aggregate it. Just a quick comment about your point on pricing and externalities. I mean, of course, that's something that's been talked about for a long time, and I think that it's a very important mechanism or tool as part of a larger toolkit, because there are certain types of externalities that are very, very difficult to price. What is the value of the existence of tigers, or what is the value of a human life? And once you start putting numbers on these and calling them like the true cost, they're not really the true cost, because it's all about willingness to pay. So I do think that in addition to pricing in certain types of externalities that we have more clarity on, we also need these more strict kind of guidelines for where certain walls are, that you should never produce something in a way that has this kind of harm, et cetera, without having a sliding scale. But I understand that you agree based on that you're nodding. So.
Okay, maybe we first take let Eva answer.
Yeah, great. I actually think that small companies are one of the biggest challenges that we have in terms of engagement, because they are actually producing the vast majority of the impact. People like focusing on large corporates because they're visible and their brands are all over the place. But in fact, overall, they're upwards of around 70 to 80% of the impact is coming from SMEs. So I do think one of the things that we've been exploring is really creating tooling that can allow small companies to do these kinds of analyses. But the biggest issue is capacity and support. So I think there could be, for example, if there were tools that companies could use themselves, they could also have a coach or someone who helps them, who guides them in using those tools and making those interpretations, which would be a lot cheaper than having a full-scale consulting process. And there could be lots of education programs and webinars, et cetera. There need to be new kind of platforms for engaging SMEs. Of course, the biggest reason that they don't participate in this is that they're mostly just completely stressed and just running after the next, just making sure that they can pay their bills from month to month. So that's the biggest issue. I don't know. There are still lots of things to work out there.
Thanks. There was a question there.
Yes, thank you for your presentation. You talked a lot about the life cycle assessment and planetary boundaries assessments, which I found very interesting. But for me, sometimes these environmental analysis still seem kind of to be in a silo. Because if you, for example, look at different options, you talked about the oat milk and, for example, then you look at soy milk. For example, I think these would show that the oat milk would be the best option. But they don't really take into account the well-being benefits of these options for society. So this also relates a bit to the pepper grinder, like how much well-being does an electric pepper grinder give? So I was wondering if you also looked into including these indicators in your analysis and how that is going.
That is another very good question. We have a whole kind of group within our company that's focused just on pushing forward social indicators and getting them to be better incorporated into different types of analyses. And we do usually incorporate social metrics when we're doing different kinds of assessments. And that's indeed one of the things that I listed as one of the pitfalls of LCA, is that it doesn't include any environmental any social or economic metrics. They are notoriously harder to measure. A lot of it is about subjective well-being, and there's not as much good data or standards for social indicators. The tool that I showed for the automated real estate assessment, a large component of that was about social quality and really looking at how buildings are contributing to the performance of a city and a neighborhood from access to resources and aesthetics perspective and all sorts of other things. And we found that actually our social metrics were the best predictor of whether a building was going to be over 100 years old, because if it was a high performing building in terms of social quality provision, then it would stick around. And that actually makes, it's a really good argument to show how these two things are very much intertwined. And, you know, of course, there's lots of judgment calls that you have to make around often there's these difficult discussions that, like, okay, well, people are doing difficult work on farms, but if they didn't have that work, then they'd be unemployed and poor. But you can also say maybe they'd be doing other things, or, you know, so there's a lot of complexity there. It's still something that we're definitely making advances on and further progressing, but it's from this integrated perspective, including our definition of the circular economy, 3 of those circles are entirely about social metrics. So that's also an important thing to take into account.
There was a question over there, yeah.
Yes, hello. My name is Thomas. I'm at DG Connect. It's my job to bring broadband to the people. So we have a political ambition. Everybody should get 100 megabits to gigabit. And I'm trying to now break down your presentation here to my daily work. What does it bring me? And I'm struck with 2 dilemmas I have, and I wanted to ask you some recommendation there. On the one hand, I think most people would agree that connectivity could solve a number of our problems we have. If everybody works 1 day a week at home, that's minus 20% carbon impact of commuting to work. However, we all know that data centers are increasingly demanding energy, so I'm not exactly sure if the overall we're doing a favor. And then more concretely, if I'm assessing on a daily basis, like how should we proceed? Do we need to dig up all of the EU to bring fiber to everybody? We have lots of discussions about that, to a lesser degree on the environmental impact that has. Well, I think I see the dilemma. Fiber is probably by far the cleanest technology. It's just sand. It uses a lot less energy. It gives us the capacity we need for the future, while using the older networks, whatever they are, keeping them, they're all less energy efficient. However, digging up the ground is probably the largest carbon impact of it all. So that would defavor investing into long sustainable solutions. So my question to you would be then, what kind of recommendations do you have for me to setting the right policies, incentives there? Because at the moment we're only talking about gigabits and euros there.
Well, it's great that you're now taking this directly to your own field and your own daily issues. So there's two problems that you raised. One is about moving to fiber more universally, and the other is around data centers and their energy consumption. So for the fiber question, I would really recommend doing a structured analysis to answer that question, because I don't have enough data or information or knowledge about those two types of technologies to be able to make a recommendation, but I know how to set up, we would know how to set up a process to answer that question. You also need to make sure that you're taking the right timeline, that you're looking at the impact over the next 50 years or whatever the lifespan is of the technology that you're putting in the ground. And then you'll actually have an answer. You'll be able to say, okay, well, yes, it's going to be there's going to be a carbon impact to digging up the ground, but in 5 years' time or 7 years' time, it's going to return itself. And because the lifespan of the technology is going to be 50 years, then overall it's a benefit. And then you can look at mitigating whatever impact there will be by inserting policies for how to do it the best way. Or the conclusion might be that actually it's never going to pay itself back because the impact is going to be too much from the insertion of that technology. But I can't answer that without the analysis. The second question around the data centers, I think there are lots of really interesting things to consider around demand side management for data centers. Are we actually running too many calculations? Is it necessary to, because right now it's extremely liberal. And actually, I know from my partner, he's a programmer, a software developer, and he's always talking about how new programmers are not focusing on memory management or data management in the way that they code, because now it's all easy. And so actually there are ways to design code in such a way that it's much more efficient. And there could be, for example, policies to improve the efficiency of the calculations that we need. And I'm positive that actually there are huge gains to be made there. So maybe looking at kind of a new era of efficiency on that demand side. And secondly, there's a lot of ways to kind of weigh the benefits. Like you just said, if people work at home for 1 day a week, then they're not traveling for a day. There are lots of ways to do structured comparisons to see, okay, where do we really get the benefits from different IT systems and where do we not? And which ones are potentially superfluous or should be taxed higher or something like that, like a luxury tax. Maybe there's a way to think about it in that way. These are just very raw thoughts at the moment. So I wouldn't, take them as like super thought through, but I would love to also think along if you have these questions further.
Guido in the back, yeah.
Just one question about the suitability of this model of development with respect to the current model that at the moment is based on global competition, where one company, one country is set against everybody else. Now, this system at the moment gives a lot of rewards on company that are the worst producers that they do not respect any environmental standards or labor standards. Now, even assuming that Europe will put in place a policy that will be, implementing all this, Europe represents about 78% of the global population. Now, don't you think that we need a lot of changes in the WTO rules? And the question to you, whether you have any evidence that big companies are putting pressure on governments to change these rules?
Well, I'm afraid I don't actually have evidence of that. And I do agree that a lot of these rules, these fundamental agreements and rules do require quite some restructuring and updating. But that is a whole other lecture and topic of discussion on its own. And I recently just came back from Davos, where there were lots of discussions among these people who are running these companies and the ILO and the OECD, et cetera, talking about how there has been a total disappearance of trust in in large corporations, because people feel like they haven't actually stepped up to the plate and done what they need to do. And the changes that we're seeing are not sufficient or at the correct pace. I really think that there are structural issues in the way that the incentives are aligned in the economic system that we currently have that prevent certain changes from taking place, and that are also preventing organizations from really stepping up to the plate for requesting these changes.
Great. Any more questions? Raise your hands, Mari.
Yeah, thanks. Very, very interesting presentation. Europe strives to become a first carbon neutral continent by 2050. And we hear more and more zero emissions cars, zero emission ships, materials, processes. Did you came across with some analyses of these ones, which in fact they are not really zero emission cars, because you use, I mean, to produce these materials, you emit CO2 emissions, and so maybe you have some examples?
Yeah, so they're zero emissions in the sense that they don't emit toxic pollution in the environment where people are breathing. And that's already quite an improvement. But indeed, there's a lot of studies and life cycle assessments that show that the carbon footprint of the materials that have to go into, for example, electric vehicles are very, very high and require thousands and thousands of kilometers of driving to pay themselves back. Now, I don't have the exact statistics on hand, but one of the things that is clear is that if we want to move to, for example, a electric car-based economy, it cannot be a one-on-one exchange with the current system. It's not that everyone who has a car now should have an electric car in the future. And also, we really need to make sure that we're not burning coal, that the actual electricity that's being put into the system is also carbon neutral, and that the materials are actually designed to be reused and recycled at high quality, at the same level of quality for many, many cycles. And then once you bring all of these pieces into place, then you can start to really look at a mobility transition that can become, let's say, as close to zero carbon as possible. And also looking at, we should be looking at a mix of different technologies, because like I said before, our studies on materials availability show that we just don't have enough materials for a full-on electric vehicle transition the way that we have, so that some people envision it.
Yeah, I have a strange question. You made very well the point that decisions in this context should be based on science, but we are going towards a very short-term democracy where, you know, professional politician has to look at just the next election, and I think there is an election every week somewhere in Europe, you know. And so the populist side is more easy, because it's enough to shout, to make promises that you will not be able to keep, because in 1 year situation will be changed and you know what happens. So my question is, do you think that our model of democracy is bad for the environment?
Yes. I mean, I don't know what more to say about that. I think there are lots of issues with our current model of democracy. It's not fundamentally resulting in, I mean, also confidence in democracy is at an all-time low for reasons that we can see. A lot of people don't feel like they're being heard. Indeed, politicians are just focused on the next election cycle. Certain decisions are being brushed away for entirely wrong reasons. So I do think that it would be amazing if we could have a better, well, that's why also governance is one of the 6 transitions that we have highlighted. Now, I do have to emphasize that we don't have the answers for how to fix this. And I think it has to be a collective dialogue and some kind of, but it would be great if it was a more active discussion to see how do we align the incentives of our governance system with the types of outcomes that we want to see for people and the environment.
A question from William there, and then...
Thank you, Monica. Thank you very interesting and provocative presentation. I have a more specific question than the last one. I have a more specific question than the last one, which is about your project that you're doing on regional Sankey diagrams. I think it's the repair project. my two specific questions on that are how many regions you're dealing with and whether you used a common methodology. And the reason I ask that, I mean, as you said, the amount that's being recycled is very small, but what is most important is actually the speed with which the materials move through there. So you have a big stock of materials and you get the maximum value out of those whilst they're in the system. And I wondered, I mean, a lot of those materials, I mean, the Sankey diagram does it by weight, so a lot of those materials are biomaterials which rot so that they have different issues related to them. Some of them are toxic, some of them are high value, some of them are low value. How you actually build into the system on top of the Sankey diagram, those kind of aspects. And I wondered whether we could use this kind of approach, if we had enough European regions doing that kind of work with a common methodology, if we could use it to sort of do some kind of smart specialization, looking at the allocation of resources in different areas and how we could use those better to get more value. And also if we could use algorithms, if we could use AI to sort of do modeling and build scenarios on top of that. So if we're looking at supply shocks or price changes, whatever it is that comes into it, that we'd actually do some modeling at European level or at interregional level if we were able to have that all that data in one space. So basically I'm saying, is what you did replicable on a much bigger basis so we could do it for hundreds of regions?
Yeah, it absolutely is. And we've already done it for dozens of regions and cities. And we do indeed have a core methodology. So material flow analysis and drawing these Sankeys is something that we do. It's kind of one of our bread and butter types of analyses because it provides us with a lot of core insight from this current state assessment. So we have done studies for a number of cities, a number of provinces. We've been doing this work across Europe. Actually, currently through Metabolic Institute, if you'd like, you can talk to Liz later. We are running a couple of projects, one called Reflow, where we're looking at doing this kind of analysis for 6 different European cities and using that kind of as the basis for a transition strategy to a circular economy. But so in our portfolio, we have quite a lot of these. Now, as a result of understanding that this is such a base methodology, we developed our own in-house tool for making these Sankey diagrams and also then for filtering that through the different kinds of metrics that you discussed. So different impact metrics. So first there's the visualization of the Sankey, and then we have these filters that show where the hotspots are, and you can actually rescale it to different types of impacts. And then the next module that we're building is the kind of intervention module that shows how you can actually change the flows of the system. Now, we're definitely looking for ways that we can apply that tool outside of the confines of our 4 walls. And we're also working toward building actually a unified cities platform for guiding cities to make these types of scans of their own area on their own, so that we don't have to do this kind of intensive process with them. So if you're interested, we can definitely discuss that in more detail later.
Okay, question there?
Yes. We have seen that bacteria, they die because they remain in the waste, in the pollution they themselves created, as far as I understand. So one of the problems I see in the circular economy is introducing contaminants so that pollution increases. Have you done a model, and what are the limits? How do you...
For me, this comes down to the design question that I raised before, because indeed right now, there's a tension between some of the policy objectives around really moving towards a closed material cycle and some of the toxic pollution issues, for example, additives in plastics, et cetera. I think that actually a lot of the legacy materials that we now have to deal with cannot really be closed cycle without introducing those toxics into the system. And in many cases, the best option is really to incinerate them with safe incineration technology and bring back, use that for energy and get the material, dispose of them in the best way possible. However, this has to be coupled with a transition to different design. We really need to be much more stringent on how we're designing products and how they're going to be ending up in the system, and also tracking and tracing of these materials and additives in those products. And there are lots of different ways to do that. But I think that this is a kind of twofold policy kind of vice that has to take place, both on dealing with legacy materials and also on and safe guidelines for legacy materials, as well as really aggressively transitioning to new product types.
Ruben?
Yes, thanks, and thanks for your presentation. I think we as policymakers are very fascinated by all the possibilities that new data is offering, but sometimes I also think that it also has the risk of giving us a sort of a false sense of security, in the sense that, like has already been mentioned, in the end it's all still based on relatively arbitrary valuation of certain elements, be it well-being, be it biodiversity. And the second point is, as you've explained yourself, even if you do a state-of-the-art life cycle analysis today, which costs a lot of money, costs a lot of time, it can still be questions saying, well, did you take into account whether this product is needed or not? So from a policy perspective, I want to ask you if you have any ideas how we can come to an assessment where we can with confidence say this is good enough to base our policies on. Because I see the risk that if we want to analyze everything down to the last number, we'll be doing that till 2050, and by then maybe it's too late for us as bacteria in the flask.
Well, I'm a really big fan of using logic first and then collecting data. So first, I think if you're considering, if you take as an example the kind of principles of circular product design or sustainable product design, and you say that, okay, if a product is designed in such a way that it is likely to get out into the environment, then it should actually be designed of non-scarce materials that are non-toxic, and it should be designed to biodegrade within 30 days at like ambient temperature and pressure. And you can start to make these kinds of logical conclusions or principles that then determine the kind of framing of how you put forward the kind of policy recommendations for design, rather than saying, okay, well, we're going to look at all these possible products that we already have and see how they affect the environment and do a life cycle assessment and try to calculate every single detail, and then based on that conclude, oh, wait, these are really harmful and we should slightly tweak the level of harm that they're doing to the system. So I think that kind of logic first approach is very, very sensible in policymaking. And also it's important to realize that you don't really, with this kind of industrial ecology thing, you don't really need to collect all the data to the last decimal. You just need the orders of magnitude, and you need to see, okay, is this harmful or not? Is this a hotspot or not? And be able to cut off some of the places where you need to do measurement based on your kind of own understanding of where the biggest impacts or concerns are going to be. Furthermore, though, I think that what I was saying is that life cycle assessment is inadequate. It's the best thing that we have, but we really need to move towards this more automated system that allows us to make science-based, much more science-based decisions around some of these types of impacts across supply chains in real time. And that requires investment, it requires collaboration, it requires combined data sets that we can all rely on. And that, I think, should be a joint effort to say, okay, well, this is the best that we can do now. We want to move toward this better system in the future. And again, not go overkill, just go to the point where we know we're getting enough information to make the right decisions. Because otherwise we waste a lot of energy and time on getting the final details when they're not really needed.
Right. We've asked a lot of questions. It's been a very intensive Q&A. So does anybody still have a burning question that they want to ask before we wrap up? Yes, the lady.
Hi, I'm Oriana Grasso. I am actually working with Copernicus, which is the Earth Information program. And apparently we are the ones giving the data and the geointelligence, so to speak. It's not only space data, it's also data coming from land sensors, air sensors, and marine sensors. We are, with DG Connect, also trying to figure out how to have this digital Earth model where, I really appreciate a lot your presentation. One small problem, AI can solve a lot of doubts, not problems, but be facilitating, let's say, can facilitate the finding a solution. The problem is that the system is very dynamic, and whatever you have as a planetary budget at a certain moment in time is inevitably going to be dynamic. Considering that there is competition already between countries on Earth that follow the virtuous path towards, life cycle assessment, the anaerobic kind of whatever. You know, others don't. As we know very well, there are people who still say that climate change doesn't exist, as there are people who will defend with their own life the extraction of shale oil or shale gas, without taking same people who actually have a lot of access to AI tools. But anyway, how can we ensure the flexibility of the analysis that we do? Because it has to be, you know, more and more adaptable. The spike that you showed before is exactly what we need to reach in terms of manageability of the analysis.
Yeah, I think one of the most important, well, first of all, we need to build tools that are dynamic themselves, that take into account changing circumstances, because it's true, the context is always different. And we are dealing with moving targets because the situation is changing. But I think a huge piece of this is really in changing the way that we govern and make decisions, and also allowing us to go into dialogues and revise things efficiently and sensibly, and also taking that into account as a core part of the process. The tools that we are developing, they are not meant to replace humans. They are meant to be decision support tools that you take the data, and there's always ways to interpret it differently, et cetera. So we actually really need to just be informed citizens who are using this data and this information to make choices in the best way that we can. And I think that that's and so those processes where we come together and make decisions also have to be very solid.
Great. We've reached, one more question. Okay, quickly.
Thank you very much. Have you taken part in designing development policies? And more generally, what do you see as main challenges to implement that framework in developing countries?
No, I haven't taken part in developing policies at all, actually. I'm not a policymaker. We do have a number of people who are policymakers or policy enthusiasts, at least on our team. But I think that a lot of the things that we're describing here, of course, as with all these other environmental efforts, the developing world has among the most to gain, because that's where you can actually leapfrog to different modes of operating. There's also a lot of these kind of circular economy practices can have huge benefits for people on the ground. But that is indeed a whole other question. We're now investigating how to transmit as much as possible of the knowledge that we have to different partners around the world. We have a small team working in the Caribbean that is really working on really technology transfer and community empowerment to transmit some of these models. And it looks very different, of course, in those contexts. But that's something I'm happy to discuss at length later, and I don't want to keep everyone here beyond.
Great. Thank you so much, Eva, for your presentation, for all the answers. Thanks, everybody, for joining us today, also on web stream and on video and in Luxembourg. So have a nice day. Thanks. Bye.